Hey guys, today in this tutorial we're going to take a look at environmental querying systems. It'll make sense what exactly that is as we go through it, but just briefly, it's basically a way for your AI to look at its surroundings or look at the surroundings around the player or like another object, and assess a bunch of different points around them to determine something to do with. So for example, if what we're going to do today is we're going to build a teleporting AI. So the way that that's going to work is it's going to get the position of the player, it's going to survey a bunch of points around the player and test them for things like, okay, is there a nav mesh and can I reach the player from here? Can I see the player from here? Is the player close enough, etc. And it's going to return a single best point depending on the criteria that we give it, and it's going to teleport to that point. So you can use EQS for a bunch of different things. Like, you don't need to use it for teleporting. You can use it to find locations to hide out of a line of sight from a player, or etc, etc. And it's not too difficult to set up once you sort of know what you're doing. It's a little bit weird because it uses some weird assets and stuff like that, but it'll all make sense as we go through. So, and by the way, I'm aware that there's that fan buzzing sound in the background. Hopefully you can still hear me over the top of it. It is just really hot here, so I need that on today. So this is just the same project from last tutorial. What we're going to do to start off is to use EQS. You need to go to Edit, Editor Preferences, type in the top here, EQS, and you need to make sure that Environmental Querying System is set to true or ticked, because otherwise the assets won't show up. So do that. Now I'm just going to create a new folder down in our content browser and just call this EQS. And inside of here, the first thing that we're going to create is go to Artificial Intelligence and go Environmental Query. And we're going to call this Teleport EQS. This one should be a short one today, guys, hopefully. It is quite simple. It's just a bit unfamiliar because, yeah, it uses some weird stuff like this thing. So the first thing that we want to do with this EQS, this is where we set the conditions for the position that we're trying to find. So we go drag off of that, and we've got a bunch of different tests here that we can do. So I'm just going to select circle for now, and I'll show you what that does. So rather than explaining this in the abstract, I'm just going to click circle, and then I'm going to right click in here again and go blueprint class, and then we're going to grab an EQS testing pawn, and I'm going to chuck that in, and I guess I can just call that EQS testing. It doesn't really matter. And this is just a thing that you can use to test the conditions that you've set in here. So if I put him in the world and then go down to EQS query template and click on teleport EQS, see that grid that's being generated, that circle? Those are all the points that this query is going to be testing. So if we go back into here now, we have a few options up here. So we can change the circle radius to 500, and now that brings it in like that. We can change the space between the points to say 200, and now they're further spaced out. What we can also do is we can change the spacing method to the number of points, and so we can have 8 total points rather than go by the spacing. So now that's got 8 points all the way around. It is good to keep the number of points to a minimum just because of like performance purposes. So let's roll with 8 for now. I wonder if you can have like several concentric circles. I'm not sure. That's okay, we can roll with this for now. So what we want to do now is we want to add the tests in here. So let's actually move that out to say like 1,000. Just for our purposes, we're going to be teleporting to the player, and we'll just teleport about 1,000 units out. I think that works pretty well. And now we want to add some tests. So we want to test each of those positions for particular criteria. So we go add test. The most important one, since this AI is a chasing AI, I'll talk through a bunch of these, but for this one, let's just go with pathfinding. So what this does is this will test each of these points to see if there is a path from that point to the querier, which is this testing pawn at the moment. The way that we're going to set this up later with the AI is, rather than have the testing pawn in here being the center or the querier, is we'll have the actual player character. So when the AI is running this test, it's going to see if we have path exist to querier, it's going to see which one of these points has a valid path from the point to the player. Hopefully that makes sense. So at the moment, the path needs to exist. That's the way that we've got it set up. If we untick this, I think we can say require not existing path, and that'll filter the results out. So the way that you know which points are being valid, they've all got a 1 and they're green right now. So if we were to go into our nav mesh, and what if we were to delete it? I'm just going to cut it really quick. And now if I click on this guy here, maybe I need to move it to refresh it. Yeah, okay, so now there's 0. So they're all invalid points now. So if I put the nav mesh back in, and maybe I could just move it across a little bit. If you press P, you should be able to see where it's working. That's the green navigation there. And now if I just move this to refresh it, oh, so none of those are actually valid because none of those points can get to the testing pawn. So if I move this across now to, like, say there, now if I refresh him, half of these points, oh, see, these are all valid out here, but it's also returned some valid points here along the edge of the nav mesh, which I guess is okay. Maybe to stop that from happening is we could add a distance condition in here as well. So if we say add test distance to querier, let's say filter only. So the filtering will have a condition. So like the filtering for these navigation ones is, can you reach the player or can you not? And it's either a yes or no. You can actually have scoring as well. So say like for distance, you could have like a desired distance that you want the point to be away, and then it could rank each of the points, give them more points for the ones that are closer or more points for the ones that are further away, and rather than just eliminating them, you can actually score them instead. I hope that makes sense, but I'm not going to do that right now. What I'm going to do is I'm just going to have this score only. Prefer greater distances. Is that what we want? No, yes we do. We want to prefer greater distances. Oh, did I say score only? I was going to say filter only. Let's say filter only. Actually, no, let's say score only. Let's roll with the score. I think that'll actually work pretty well. So now you can see what we've got here is we've got all of these points on the outside that have got a score of 1 because they're the perfect points. They're the furthest away and they've got a path. But these ones in here, they have a path, but they're closer than the ones out there, so they have a lower score. So when we run the test in the behavior tree, it'll pick one of these ones with the high score and teleport to one of those. But you can set this up however you want. If I'm going to have a teleporting AI, I'd want it to teleport at a decent distance away from the player so that it wasn't unfair on the player when the enemy teleported on top of them, just like that. And you can move this around and it'll update and everything like that. So hopefully you're following me so far. But again, like, you can do whatever you want with these tests. Like, you could add in a trace, for example, and you could require, so say if you had filter only, you could require a hit and don't score, but it only filters. So what we could do is we could untick that and require a not hit. And I guess they're all hitting because the testing pawn's in the ground. Yeah, okay. So now they're not hitting because they're up in the air like that. So yeah, you could use this one, for example, like if you had an obstacle in front of one of these points and you didn't want the AI to teleport on the other side of the obstacle where the player was out of sight, then you could use the visibility test. So I'm just gonna, oops, let's not delete that. Let's just delete this one down here. Can I do that? What if I just untick it? Let's just untick it. So we're going to use distance and we're going to use the path finding one. If any of this doesn't make any sense, by the way, or you get stuck, feel free to drop me a question and I can do my best to help you out and answer it. This is a little bit tricky the first time you do it, and unfortunately, like, I couldn't really find a whole lot of good tutorials. There are a few good ones out there, but yeah, they're sort of few, so have a look at some other tutorials and see how other people do this as well, not just me. But anyway, what was I going to do now? So now that we've got this EQS set up, that should actually be ready to go. Okay, so no, it's not. What we need to do is we need to change the context. What the context is that's the center of the test. So at the moment, the context right here is the querier. So that's the person running the EQS. So in the case of this testing pawn, the querier is the testing pawn. But if we're running the EQS from the behavior tree here, we don't want the querier in this case will be the actual AI, and we don't want to run the query around the AI. We want to run the query around the player. So I'm actually not sure how to do this, but let's see if I can find a query. Environmental query context blueprint base. I guess that's the one we need. Bear with me while I figure this out. Let's just call this player EQS query. I mean, I've done this before, but I'm a little bit rusty. It's been a while, so let's see if I can remember. Player EQS query. Let's open that up. Now, I believe what you want to do in here to set this to use the player as the querier is you want to go into these functions, and where it says provide single actor, we want to go into that, I think. What else have we got in here? Provide single actor. Yeah, let's roll with that. And the resulting actor, so in the querier context, the querier actor is just plugged straight into that. So what we could do here is we could just say get player pawn, and then just plug that into there like that. And now this should use the player as the query, the query context. So if I were to go into our teleport EQS, and if I were to change this to our player EQS query, this should break the pawn because there's no player in the map. And it doesn't do that. I wonder why. Did that actually change? Player EQS query, yes, that is definitely... oh, sorry, maybe I was just selecting the trace one, so we need to just reset that. Click on the entire, whatever the hell you'd call this, on circle, generate items, blah 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 blah. Set the circle center to the player EQS query, and now let's see what happens here. So now that's broken because there's no player in the map. So that's what we want, I guess, for now anyway. So now what we do is let's give this guy a teleporting ability. So for the time being, let's just disconnect his chasing mechanic, and when he can see the player, we're going to run a sequence. And what the sequence is going to do is maybe we'll wait for a second. Then what we'll do is we'll run EQS query, and the EQS query is how does this actually work? I'm not even sure. This is deprecated. Oh, down here, EQS request. This is the one. This is where we set the query template. So go down into here and go teleport EQS. So now what that's going to do is it's going to run that EQS, and it's going to return the location of the best point. And I think we can have different run modes, so we could get the single best point, or we could get a random item from the best 5%. Let's roll with that. And what it's going to do with that location is it's going to set it to a Blackboard key, which is going to be our move to location. And then I guess what we could do, well, we want to teleport to that location, so let's just create a task for teleporting. This will be super easy. Go back into your content browser now that we've got that new task, and just call this basic teleport BTT, and open that up. And when we receive the execute from that, how are we going for time, by the way? 13 minutes. We're doing well. So the controlled pawn, we're just going to set actor location. Sorry, set actor location. This is a really simple teleport, and the location we're going to set it to is just going to get a vector. Get key. Get Blackboard value as vector, because we want to use a Blackboard key for the teleport location. So we can promote that to a variable, and that can be just called teleport location. And we want that to be public as well, so we can edit it in the behavior tree. And then let's just spawn an emitter at the new location, I guess, just so we can see where he's teleporting and etc. Actually, let's spawn the emitter at the beginning as well, just to add some cool effects and stuff. Let's get the controlled pawn location. So get actor location. Okay, that should be all good, I think. No, we need to finish execute. Always remember to finish execute, otherwise your behavior tree will just get stuck on this task. Okay. We can close all of that down now. So now that we've run the EQS query, we can say teleport, basic teleport, and the teleport location is going to be the move to location that we're setting in here. If we wanted to, we could go to the Blackboard and we could create another vector and call this teleport lock, like that. And we could use that instead of the move to, but it doesn't really matter. So in here now we could say teleport location, and this one could be teleport location. It makes more sense, it's more readable that way. So after we teleport, I guess we could just wait again, and then he'll just after that's complete, this whole branch will be a success, and then the root will fire again, and then he'll teleport again. So this is just for testing purposes. What you'd do is you'd have him chase you after he teleports. I'm just deleting the testing pawn right now, and I'm just going to reset this nav mesh so that it's nice and big. Okay, so when he sees us, he should start teleporting around us. Okay, so he's roaming now, and now he should have seen us. Oh, teleported. Check that out. There we go, it actually worked. And now if I wait, oh, he's roaming again. Teleported. He went to that point over there. Yeah, cool, okay. And we have an error. Let's see what that's all about. Tried access null trying to read health bar component. I've got a feeling that's an error from something I did right at the end of the last tutorial, which we really didn't need to set up, to be honest. What's this damage component? We don't need that for this tutorial, so let's just get rid of all of that. That's actually working. That's working really well. What we could even do is, if we were to put this up like this, so that he is too high for him to walk up to, he could actually teleport up here and chase us, continue to chase us. Let's just check that the nav mesh is working up there. Yes, it is. So now if I were to jump up here, and when he sees us, he'll probably teleport up here. Has he seen us? No, he hasn't. Okay. Okay, now he's seen us. Oh, but he's not turning once he's seen us. Okay, now he can see us, definitely. You gonna teleport, my dude, or what? He's not teleporting. And I wonder why. Let's see. Why is that still... Who has a health... Oh, it might be in the player character. Just tap the right arrow key if you want to skip forward. I'm just fixing some stupid shit I did in the last tutorial by the look of it. Damageable component. What if I can delete that? Maybe I just need to delete that from our patrolling AI as well. Yeah, okay, that's gone. Sorry about that, guys. Now, why the hell isn't this guy teleporting up to the top there? Maybe what we could do... Well, a good way to test this sort of thing... let's chuck our testing pawn back in and let's just see what it looks like up here. Maybe this is too small for... Oh, there could be a bunch of reasons why he's not teleporting up here, so let's just check. So we'll chuck in the EQS testing pawn up there. We'll add the query template to the teleport EQS. Then what we need to do is we need to go back to the teleport EQS and we need to change the circle center back to the querier. Alright, now let's see what's going on. So all of those points, they should be valid up there. I guess it could be a problem with his line of sight. Maybe he can't quite see us or something. So what if we just drop that down a little bit lower like that? And we'll see if we can get him to teleport up here now. Okay, so if we go back into the teleport EQS before we run, and we change that back to the player query, we can delete the testing pawn. Okay, so that's definitely too high to walk up. And if he sees us now, is he going to teleport up here? Let's see what his behavior tree is doing. Okay, so this is failing, I guess. What's this down here doing? So he's trying to return to the origin, but I guess that's just because this is failing for some reason. Alright, give me a sec, guys. I'm just going to pause this and figure this out. I'll be back in a moment. Alright, guys, I figured out what was going on. So if you go back into your teleport EQS thing, hang on, just let me shut my door. If you go back into your teleport EQS asset, what you need to do in the path exist from querier, the context of this path existing is currently running from the querier to, I guess, the point that's in question. In the case of being up on this block, the path from the querier to the point is broken because it's up on a ledge. You can't walk there from there. So what you need to do is you need to set this to the player EQS query, because what we want to do is we want to check if there's a path from the point in question to the player, not from us to the player. So hopefully that makes sense. And for the distance as well, the distance, we don't want it to be from the querier to the teleport point. We want it to be from the item. We want it to be... Is that what we want? The item to the player? I'm not even sure. I'm going to guess it's probably from the player. Let's go from the player to the point in question. I could be wrong about that, but I can't be bothered thinking about it. My brain's getting a little bit sore. So anyway, if we jump in now that we've set up that player context for the pathfinding test. Okay, he can see us now. He's teleported. Where is he now? Oh, there he is. He's up here now. So now he's teleporting around up here, and he prefers the greater distances. So he'll probably just keep teleporting to either side. Oh, he's lost us. Now he's seen us again. So something else that we should probably do for this teleporting thing is in our basic teleport thing, right? When we set his location, let's actually set his rotation as well to face his target. So we'll say set rotation, set actor rotation. This would make more sense, because if he's teleporting while he's chasing us, we want him to be facing us when he teleports. Now for this, we say find look at rotation. The start of the start's where we are, and the target is going to be the target location. Do we have a thing for that? Alright, so let's just say get what is it? Get as actor? As actor. We want to get Blackboard value as actor. The key is going to be target key. Make that public, and then we say get actor location, and then we plug that into the target. So now it'll find the rotation required to look at the target from where we are, the actor. Okay, so if we go back into our behavior tree, we just need to set the target key to the target, just like that. Now that should be all good. He should be working now. So if I just dock that across to the side and then open up our behavior tree. So he's teleporting, finding lots of good points. He's preferring the furthest one, which is always going to be way off like that. Yep, that's good. It's working. Now he's over there. And he's always facing us. When he teleports, he's always facing us. And if we walk off, he teleports down here again. Cool. Now the other thing that we want to do is just to integrate this back with our other system. Let's just drag off a sequence node there. And this can be the teleport sequence here. So we could even just get rid of that weight off the end like that. Or to be honest, we could even... Oh, let's put this over that side maybe. So he'll teleport, when this starts he'll teleport, and then he'll wait for, I don't know, let's say 1 plus or minus 0.5 seconds, and then he'll continue to chase us maybe. That could be pretty cool. And he had a projectile launching thing, so... what would be a cool way to do this? Maybe what we could do is we could constantly be moving towards our target. And then what we could do is we could launch a projectile and then teleport and then teleport. Yeah, that'll work. Just keep it simple. Now this wait blackboard time, that was his projectile fire rate, which we could use later, so let's just leave that off like that, and let's just have this like this. Just for now. So what this is going to do, simple parallel node, he's always going to be moving towards the target. While he's moving towards the target, he's going to shoot a projectile, and then he's going to teleport. Actually, let's have a wait in there. Maybe this can be the wait blackboard time. That could be the time between shooting and then teleporting. So he'll shoot at the player, he'll wait the time, then he'll teleport to a new location, and then he'll wait at that new location for a little bit, and then this will repeat. Yeah, cool. That'll do. Oh my god. That's not working how I thought it would. So maybe this here can just be a little bit longer. Let's just put that as wait, I don't know, like 3 seconds or something. And then he'll teleport. Oh my god, he's really fast. So he's teleporting. There we go, that's the teleport just there. Oh, now he's over here. And then if we... oh fuck, I just jumped off the edge. That explosion, by the way, is the sound that his projectile makes. We set that up in the last video. So now if I jump up here... oh, he's lost sight of us now, he's facing the wrong way. Yeah, you can't seem to see us when he walks up with this. Oh look, you know, I can't really be bothered fixing that right now. Maybe in the next video we could tidy this guy up and do a bunch of different things to make him actually look like a valid enemy. But the point is, like, even though this didn't integrate too well at the moment, we could play around with that and come up with some new behaviors to make it work a bit better. The point is that the EQS works, and you can have all different kinds of there's all different kinds of things that you can do with this. Maybe in the next tutorial what we might do is we might set up a component or a task rather, to make him constantly face the player while he's chasing. So as you saw when he was brushing up against this ledge here, he was facing out to the side rather than looking at the player, and it caused him to lose sight of him even though he was chasing. So what we could do is just constantly update him to yaw around and face the player no matter where he goes. But that's basically an EQS tutorial done. If you have any questions about the EQS part, like, drop them in the comments. And I'll do my best to get back to you, but yeah, I'll tidy this guy up in the next tutorial, and we'll see if we'll do some other cool things as well, like we might get him flying and stuff as well. So let's just leave that there for now. I'm gonna go have some food and chill out. See you guys in the next one.